All right. So it's 18 hours on the dot. Just want to ask if you can hear me.
Yes, sir.
Beautiful. Thank you very much. So as I'm setting up, I'm just going to share my screen. I just wanted to find out if people have any specific questions related to what we've covered so far, and perhaps specifically some of the things we went through yesterday when we were discussing so-called use case descriptions. Just wanted to point out that our focus was really on the tabular notation, which we introduced as part of the lecture series number 6, I believe. I don't know if people have questions.
Yeah, I do. First thing first, this one goes to my colleague. I've just realized that it's important that after the session, it's important that we all log out, because if someone remains, the session will continue recording even when there's nothing happening, and you find that the video belongs for nothing.
Right. So yeah, that's an important point. I mean, we've had numerous such instances. Now, if you do notice that, it turns out that it's, by the way, if you do notice that as you're consuming the video, because I don't play these things back when they're recorded, all I do is I dump them, right? I dump them on YouTube. And occasionally there are some sessions that I'll probably play back because I splice them up and I remove chunks of the recording that might perhaps be of relevance to some people out there, right? So what I'm trying to say is, if you come across a recording that has been shared, and oh, I think I know what you're talking about. It must be this. I didn't realize this is like, I don't know if you can see, this is like 1 hour, excuse me, 1 hour 37 minutes. So all you have to do is you must tell me, right? You must tell me to say, can you, although I mean it's a bit difficult here, you must tell me to say, can you please edit out the recording? It turns out it's not that hard. All you'd have to do is, and there he is. It's the infamous Aaron, right? The culprit. All you have to do is, once Lighton says bye here, all I'll do is I'll probably splice it out at the 52nd minute, right? 52:27, maybe even before, when I was logging out here. So it's quite easy. I don't know if people use YouTube or something, but it turns out it's not that hard, right? So all you do is you edit it out like so, go to details, and then you use YouTube Studio, obviously, there's an editor which is pretty easy to use. I mean, obviously, I mean, doing this on your computer is probably going to be a lot more effective because you have control over the editing software that you're using. But nonetheless, I mean, it's not that. So you trim, and then in this case, I'll just drag this all the way from the first second all the way up to the 52nd second, right? And then just say I want to go all the way up to the 52nd, which is here. And you can see where Aaron is here. Just boom. But sometimes, right, the reason why I normally don't, even when I play back the recording, sometimes there'll be conversations that people are having. There are sometimes beneficial conversations. In some courses that we have, students who actually make use of this platform to discuss the lecture afterwards. And this is what you should be doing at this stage in third year, right? And so maybe the segment after the lecture might have some useful conversations that some people might want to play back afterwards. But still, all you do is you tell me, and then it will be spliced out into two separate videos. So the first video, I would splice it out like this and say, this is a lecture, and then the other one is a discussion, and then upload all of them. But great contribution. Any other issues that people might have? Does anyone use YouTube?
Yeah, I have a question.
Anyone in the house using YouTube Studio? Hello? Who uses YouTube Studio? What do you use? What do you do? What are you going to be doing when you start? Anyway, all right, questions?
Yeah, okay. Before I ask the question, sir, I just want to commend your effectiveness in terms of your response. I missed yesterday's lecture, and I was remaining 50 minutes to catch up. So I had to send a mail. And
yes. Thank you very much. And I know I'm effective. I know I'm very effective, actually.
Yeah.
That was me.
Yeah, you should keep up with
on the pedestal here. Yeah. Okay, sure, of course. I mean, we understand that for some people, I mean, the vast majority of you actually don't attend the live sessions, and so the recorded lectures are pretty valuable. That we understand. And unfortunately, I mean, there are instances like I don't know if people noticed there was a session we had one of the weekends, and I think Matong is one who reminded us that we weren't recording. So it's a short segment that we ended up recording, just 9 minutes of the entire 1 hour long lecture. It's a bit unfortunate, really. But anyways, yes, the question.
Yeah, the question is on the use case description.
Okay.
So, for example, let's say our software has got maybe, let's say, 5 or 3 actors. So each actor is supposed to have a use case ID and the description. Like each,
No.
each actor is supposed to have a how is it like the way it is? So you have
No.
a use case description for each actor or
No. So the idea behind these use case descriptions is I don't know who has the microphone on. Maybe you switched off or something. Here's the thing: this description here, this tabular notation that we're using here. Each one of these tabular notations, use case description, use case narrative, is supposed to map onto the use cases that you have in your use case diagram. So in fact, the first starting point, before you can even come up with a use case description, you must come up with this, the use case diagram. The use case diagram will have all the features associated with your system, all of them. And so each one of these, once you have a comprehensive set of use cases, right, these features, these ovals here, each one of these things here is supposed to have a corresponding use case description. So essentially a table dedicated to this. Now it's not like you're supposed to have an ID for an act and whatnot. In fact, if you look at the use case description, because this use case name here serves as a basis for creating the use case description, what you do to come up with a relationship between the use case and the actor is you include the name of the actors that interact with the use case. So for instance, if we were to create a create account, okay. If we were to create a login use case description. Now this is a bad example as well. Okay, the create account anyway. If we were to come up with a use case create account, use case description create account, somewhere in the description, there's a provision where you have actors. You just list the actors that are going to interact with the use case. And if you think about it here, you realize that this is all important information that the program is going to require as they're implementing the software, right? In this case, like it would be specific to what sort of access levels associated with the different user roles, right? Now I'm going to briefly open, wow. I'm going to, okay, it's not here. I want to open the actual use case template that I was filling out when I was coming up with that thing. I guess maybe it's going to be templates. So observe. The use case that I have in this template here, it's one of, because this is mapped onto the example control plus. This is mapped onto the exemplar project, that the SIRD, right? This use case description or this use case narrative you're seeing here is one of 1, 2, 3, 4, 5, 6. So in fact, my SRS document must have 6 such things. Somewhere in this table, in this template, you have this. You see this part that says actors. So if this use case in just digital object required that maybe a library staff interact with it as well, then would have postgraduate student, library staff. Okay? This is what you do. So I don't know if that answers your question, but maybe not.
No, not really, sir. I'm not clear.
Okay. Do you want to rephrase the
yeah,
question?
okay. For example, just the example you've given, you say you list like postgraduate students and the library staff, and the like. So are the description for the postgraduate student and the library staff going to be the same?
No, but you don't need to. Yes, because what you're describing here, good question, by the way. What you're describing is not the act itself. You're describing the use case. This is the description of the use case itself. If you read through this description, this is supposed to be a description of this use case here. What the use case does, what that feature is all about. It's not a description of the actors. So this narrative we have here has a couple of components. You specify which actors are going to interact with the use case. You specify a brief description of the use case itself. You specify what triggers the interaction with this use case. There's always a trigger. You specify conditions that must hold true for the actor or the actors to be able to interact with the use case. You must specify the post conditions, what happens to the system afterwards. There's always something that happens, right? When you perform an operation on using a computer software, there's always something that happens, right? So you specify the post conditions. And then you specify the normal flow of events, the sequence of events that happens as the actors are interacting with the use case. What happens exactly? Or click a button or something. Or, you know, I'm being here more detailed here, but I'll click the login button. And then once I click the login button, once the system will verify my credentials. Once my credentials are verified, the system will present me with a dashboard, right? And then it's done. And then alternative flow is what happens when the preconditions are not met. These are not alternative flow. Exceptions are potential flows that can happen and what exactly that entails. Includes is if you have a sub-process that you need to incorporate into this use case using the includes keyword or the extend keyword or uses keyword. Priority, very important. You want to specify the relative level of importance of this particular use case. And why, you ask? Why you ask? Think about this for a second. Let's say you're a business analyst and your task is to develop this SRS document and you have these use cases in there. You ship it to some programmers in India, very common now, I guess, or China, because it's cheap labor, right? They need to know which of the use cases are of high importance, the ones they should start implementing first, right? So this is important. Frequency of use, I mean, these are just add-on information, like you want to specify things like at its peak, how many users are going to be utilizing the system or something. If you have specific business rules associated with the organization for which you're implementing the software, you cross-reference the specific business rules that you're latching onto. Now, we didn't really discuss business rules per se, but if you do a more detailed system analysis course, you probably discuss some of these things, right? We're glossing over most of these ideas or concepts. And then the assumption is whatever assumption you're making, right? For this thing to actually, for this use case to actually exist in the first place, or for an act to be able to interact with this use case, are there any assumptions that you're making, right? And then any other notes or issues that you might have, right? I don't know if this makes sense, but does that answer your question?
So in other words, it's more like we are talking about the interaction between the actors and the use case.
Yes, and the feature, the use case or the feature, the system feature. Yeah.
Yes, now, okay, so I twisted it. Now I've gotten the point. Now, for example, here you list the actors. Let's say there's postgraduate students, you list the library staff and the student. But the description is only talking about the interaction between like the student and the use case. Then how are you going to include the library staff and the student?
Oh, so but that's just English, right? I mean, you could say, you could just rewrite it whatever makes sense. Postgraduate, a postgraduate. You could just say a postgraduate student, comma, library staff.
We can't hear you, sir.
Hello, are you still there? Hello, are you still there? Can you hear me?
Yeah, we can get you
we
now.
can hear you now.
Yeah, so there's something happened here. There's a slight power outage, and I'm using a router that needs to be constantly powered. I don't know why I'm not using the Wi-Fi, but anyway, I do apologize for that. Is my screen shared still? Is my screen visible? Is it shared?
Yes, sir.
Okay, great. Right. So I was saying, I mean, so it's just a matter of just rewriting it so that it takes into account the other actors involved. So you could just say a postgraduate student, library staff or administrator accesses because it's just a description, the SRS system using a browser, and then boom. Right? So you're describing just what sort of interaction is going to happen with the use case. So if you want, you can, if you have multiple actors here, you can just say the system user or something accesses, because the person reading this will know. So if I write this to say the system user or users access the SIRD system using a browser, but the person reading this will not say, oh, the system users, this person or these people are referring to are these actors here. It's just a matter of writing this thing.
Okay, on the same thing.
Yeah.
Now you find that amongst the system users, there are some users who have got a limited access to some options. So if you just make it general that the system user, again, won't it complicate the operation of the system?
No, it won't, because what you're referring to here is an interesting thing here, right? I don't know if people have picked up on the fact that we started our discussion from describing functional requirements down to describing specific details associated with the objects, right? So attributes and operations associated with the object. And then at some stage, that's like structural models, right? So we started from interaction models, right? And then structural models, and then we're going to look at the behavioral model. In all these different instances, you're talking about different things, right? In the first part, you're more concerned about the functional requirements. In the second part, you're concerned about the attributes and the operations associated with the objects, right, related to the system you're developing. And then finally, the actual, the behavior, right? The behavior of the objects as the user is interacting with the system. So it won't because what you're describing here is this particular use case. Now, the mere fact that you have multiple actors here associated with this use case simply means that all of them need to have access to this use case. If you have a situation where there are certain specific things associated with this use case that some actors are not supposed to perform, and this is a part where you break up that use case into sub-processes, right? And you have the includes and the extend, right? So that you specify that that some of the operations are not supposed to be performed by certain users. I don't know if that answers your question here. But this just saying system users, it doesn't change a thing really, because what you're doing here is you're making reference to by system users. These system users are these people here listed as actors. Again, the person reading this will know, right? And what you're describing here is this use case here, ingest digital object in this case. These are just features to describe.
I'm clear, sir.
Okay. Any other questions that people might have? Have you gotten to a stage where you've started drawing these use case diagrams as a group?
Oh, Doc.
Yes, sir.
Yeah, I just want to clarify, like, what's the main difference between the alternative flows and the exceptions? Because from what I'm seeing on that description table, it's like they're just the same.
Right. I guess this is best explained from perspective of maybe some of the things that, here's the thing, right? I'll use this as an example. Great question, by the way, Jackson. So I'll use this as an example, right? So observe, I'm saying that the preconditions here is that the student must have a valid account, right? Yes, that's one precondition. Are we together? Yes.
Yes.
The second one, the second one is the postgraduate student should be logged onto the system, right? Assuming these are our two preconditions. The alternative flow spells out the sequence of events in the event that either one of these things is not true. So if the postgraduate student who is attempting to use this use case does not have a valid account, then nothing will happen, right? So you need to have an explanation for what happens, right? Alternative flow. And this is where I'm saying maybe the things that I see where you are coming from here. These things I had here are associated with these alternate statements I have here is supposed to be linked to the preconditions. So alternative flow would be, yeah, I see what you're doing here. Postgraduate student is notified or something to create account. This makes sense, sorry. So the alternative flow is supposed to start making reference to, I see what you mean. We're supposed to make reference to these preconditions, not what I was doing here is I see where this is coming from. I guess it was just me, I was in a hurry or something. They appeared they were the same because we're talking about the same things here. But ideally, your alternative flow is tied to anything that is going to be associated with either one of the preconditions being false and not true. So if the student is not logged on to the SRS system, what is alternative flow, right? Maybe the first thing is the system will prompt the user to log in. And you've used tools, you've used software like this where you're attempting to, I've used this myself, you're attempting to, I don't know if, Facebook is a good example, right? If you go to Facebook and you attempt to, I don't know why I'm going, watch God, right? If you, I don't know why, but if you attempt to log into the Facebook, for instance, it will prompt you to log in for you to perform certain operations, right? You can't do certain things, like you can't comment, you see this, right? So anyways, what I'm saying is the alternative flows are supposed to point to the preconditions here. So you're supposed to be talking about sequence of events that arise because the precondition is not true here. So a student doesn't have a valid account, a student is not logged on, right? So maybe the first thing the system will do is prompt the user to register for an account or something. Or for this particular precondition, it's prompt a user to log into the system, right? So that's an alternative flow. And then the exceptions are things that can go wrong. This is the thing here. Exceptions are things that go wrong once the user is interacting with the use case. So assuming the preconditions are true and the user starts interacting with the use case, what are the exceptions? And you discussed exceptions, right? These are bad things, right? You discussed exception handling in 2010, right? This is exactly what we're talking about here. Yes? Try, catch, blocks, and whatnot.
Yeah,
exactly. These are the exceptions we're talking about. So what we're saying is that the things that can go wrong once the user is interacting with the use case. And it's contextual. It depends on the use case you're describing, really, right? So perhaps as I am trying to ingest a digital object here, I will attempt to upload a file that's not a PDF. And because we expect this PDF, one of the business rules for this particular application is that you must upload PDF documents, then that's an exception, right? So the system must behave in a certain way, right? So I don't know if that clarifies the difference between an exception and alternative flow.
Yes, very much.
Beautiful. Okay, any other questions? Okay. If there are no questions, then I guess we continue our discussion of, and hopefully you've started interacting with Lucid, sorry, not Lucid, but you've started interacting with, Lucid Chat. I don't know if you've discovered that there's nowhere in Lucid Chat where you get to create use case descriptions, right? It's not part of the UML specification, these narratives, which is why we have that separate template that's available in the Moodle. So you'll not find these there. Anyway, good stuff. So I thought now would be a good time for us to talk about structural models, and then hopefully day after tomorrow we can wrap up with behavioral models, and then we can stitch together different parts that we've spoken about on Friday. And then over the weekend, I want us to start looking at configuration management, and then I think we'll be on track or something. But so here's the thing, right? Again, this is what I was talking about. There's a story we're trying to tell here, right? We are really discussing different levels of abstraction when it comes to developing software, right? So the interaction models that we were looking at, specifically use case diagrams, you notice we are more concerned with the features, the high-level description of the functional requirements, right? And then now we're going to get into structural models where we get to look at attributes and operations that are associated with whatever objects that we would end up creating once we implement this piece of software, assuming we're taking an object-oriented programming approach, right? So enter the world of class diagrams. And I know this is probably going to be revision. I believe you looked at this last year or something. Somebody had mentioned that you discussed this last year, right? You looked at UML class diagrams last year?
Yeah, though we didn't do some things.
Okay. Well, anyway.
Yeah.
So a UML class diagram is nothing more than just a graphical notation that represents classes associated with the system that you're developing in the event that you're taking an object-oriented programming approach, right? And then you probably had this formal definition of what a class is, and an object, right? A class could be viewed as being something that models something that represents something in the real world, and then an object would be an instance of the class, all those nice things, right? Our focus though here is, before we start looking at the notation itself, just wanted to remind us that a class is fundamentally composed of three key things here. You have attributes, operations, and the different associations between the different classes. Typically, when you're developing software using an object-oriented programming approach, part of what you do is you model the relationships that exist between the different objects, how the objects are going to end up interacting with each other, right? Although I guess last year you probably focused more on associations like, or relationships like generalization, I guess. I don't know if you looked at aggregation and composition and all these things. I don't think you looked at multiplicities, like trying to, it turns out that for most people, when you're coming up with UML class diagrams, what you tend to focus on are the more important, I guess, what people consider more important relationships. So if you have standalone objects, you rarely come up with a representation similar to this, where I'm saying a user deposits a digital object, right? But it turns out this is supposed to be part of, it's supposed to be included. You typically have these sort of things when you're coming up with the entity relationship diagrams or something. We have no, we do many to many, right? All right, so you have, the class will have attributes and operations, and also associations between the different classes. And essentially what your UML class diagram will do is it will, again, we're still abstracting things here, right? It will abstract the gory details of the implementation by not focusing on details to do with how exactly instances of the different classes are going to interact with each other, right? So we have, sure, we know that we have a user class and a digital object class, and there's this sort of association that exists, but we're abstracting the details of the interaction that takes place when a user is depositing this digital object, right? We're only interested in modeling the association and things like the attributes and the operations associated with these objects, right? So we're still abstracting here. Incidentally, the modeling of the interaction that takes place is done using behavioral models like sequence diagrams, which we look at. And we discussed this, right? If you remember our discussion of these sequence diagrams, made mention of the fact that part of what you do with a sequence diagram is you specify implicitly the lifetime of the different actors and objects, right? Anyways, we'll look at that on Friday, I guess, or Thursday. Okay, so you also don't provide specific details of how the class behaves, right? So you omit all those gory details. All you're interested in is just specifying the attributes, operations, and the associations, right? Okay. And then in terms of still on the different aspects and specifics to do with the notation of the class diagram, it's usually, but it's represented by a rectangle, right? So what you're seeing on the right of, I don't know if it's your right here, of the slide here, is how you represent a class using UML notation, right? UML class diagram. It has 3 segments, right? So the rectangle is split up into 3 segments. The first part is the class name, digital object. The second segment is reserved for attributes, right? And then the bottom segment here is reserved for operations and, you guessed it right, constructors. I don't know if you remember these things. So if obviously class will almost always have constructors, right? Loaded in different constructors and all those fancy things. So the constructors will be slotted into the last or the bottom segment here. Right? So 3 components, really very simple thing, and you can see them here, right? 1, 2, 3, 1, 2, 3. Everything has 3 segments here. Attributes, operations, class name. Okay, so like I said, I mean, class names are specified in the top part here. But if you remember, if you're using classic languages like Java, there are certain well, you actually make use of certain constructs other than classes. They're perceived as classes, but not really classes, right? So things like abstract classes and interfaces. It turns out that they're presented in a certain way in UML. So a class, while a class is represented the way it is right now, right? Camel casing is what you use. An interface is presented in such a way that you have these double chevrons with the weight interface on top of the class name. So if this digital object thing here was an interface, we would have had to do this. We would have had to do this, right? Yeah. Would have had to do this. Is this making sense? Right? So this would signal the fact that this is an interface. No, this is, you might sit there and you're thinking, why are we doing this? Why is this important? One of the reasons why this is important is associated to what we discussed, I don't know if it was last week or the week before, when we were talking about model-driven engineering or model-driven architecture, where we said that the byproduct of that process is not software code, it's the models. And the rationale, the reasoning behind that is that you automatically generate code using the models, right? The only way you'll be able to generate the correct code is if you follow the rules. So if we were to automatically generate code for this, what would generate would be an interface and not a class. Right? And you remember what an interface is. What's an interface? What's the difference between an abstract class and an interface? Don't know. So the abstract class is represented in italics, right? So if this was an abstract class, what we would do is would remove this interface with double chevron, and then would just put it in italics like this. And then we'll know that this is an abstract class. I'm curious, what's the difference between an abstract class and an interface? Moses, what's the difference between an abstract class and an interface? I can see you're there, but you don't want to say anything. Anyway, I don't know. Nobody cares. I mean, what we care about is, I guess, how we represent these things. For this course, we don't care, but if I were you, I would remind myself of what those things are, right? Anyway.
Oh, actually, sir, we didn't look at that.
No, you did. In 2010.
So it's a new thing. We didn't.
Oh, okay.
We didn't.
Hello, sir.
Yes, sir.
The interface allows you to like understand the functionality. Then what's this? The abstract
Like the interface allows you to understand or to define the functionality, while the abstract is to create the functionality.
Yeah, I mean, to a certain extent, I mean, you're on the right track here, right? I mean, it's and that's what I was thinking about interfaces is if you look at it from the perspective of implementation of the methods that you have, right? An interface will not implement any methods. It's just like a skeleton. You just have a signature of the method in an interface. Well, an abstract class might implement a default behavior of the method, right? And all these things have like huge implications on in terms of when you use them and when you don't use them, right? I'm surprised. I'll have to ask Pierre. I thought this was, maybe you've forgotten. You always say you didn't discuss this, but that's fine. Yeah, but we are just interested in outlining the difference, how you represent these different constructs, right? So a class would be represented like this. If this was an interface, would have the double chaperone with the word interface in them up on top. If it was an abstract class, this word here, this object would be in italics, right? This is what we're saying here. So in terms of the second segment here, talk of the attributes, right? So the syntax is quite simple, really. When you're defining attributes in the middle segment, you specify the visibility of the attribute, the variable name of the attribute, the data type of the attribute, and optionally the default value associated with the attribute. Oh, I didn't finish this. No, it's supposed to be an explanation. Yes, it's fine. So what we're saying here is that for each of these things that you have in this segment here, you're supposed to specify the visibility. You remember I think we talk about the visibility here. Yeah, we talk about the visibility. I don't know if people remember the visibility of attributes or variables in a class, right? Default, protected, private, package level. Well, package is default, I guess. Yeah, all those different things we looked at. I don't know if people remember these things. Private, public, private, protected, package, right? Default. It's not that hard. But anyway, so this is the syntax that you have here, right? I'm going to talk about this so that we understand. Okay. So anyway, I'm trying to see if we had, looks like we didn't. Attributes and operations. Okay. So in terms of the attributes here, what we're saying is that you specify the visibility, the variable, the data type, and optionally the default value. Now, if you look at this syntax here, in some instances here, in fact, in both instances here, we don't have the default value specified, right? So meaning that when we're writing code, we wouldn't really, if we were to translate this into Java code, say public class digital object or something, what we're saying is that we would have, and I wish I had, I have IntelliJ, I think. Yes, I don't know. I don't know why I'm even doing that. It's Java, set this as the .java and then it will know, I think. Shouldn't have done this with, okay, it's not working. Second, I'm just trying indentation. Because this thing is bloated. The thing that I just opened is bloated. I need to close it. I made a mistake actually. Just give me a second. This was a huge mistake. This was a huge, I would have loved to use this, I mean, for auto indentation and whatnot, but I don't want this thing to freeze. Just need to close this thing. So what we're saying is that the visibility we're talking about have huge implications in terms of what you have here, right? So this object identifier, you would have something like private because it's negatively private string identifier, right? Identifier, right? And then you have private, this is still private, static, private static, int type, right? We talk about this just now, and then in here is where you have your methods or something like methods and whatnot. But what we're saying, right, guys, is that if you notice here, if we had a situation where we wanted to assign a default value to, let's say, the type variable, if the code has something like this, right? Or this is an int, let's say 1 is a default. What we would have done with this type thing here, this type attribute, is would have gone to Lucidchart in this case, and would have gone go to Lucidchart, and then we go to type, and then we say is equal to 1. Right? This is the syntax. So this signals the fact that the type attribute is assigned a default. It has a default value associated with it. It changes back to normal font face here, not italic, because it's a class, right? So yeah, so just take note of the fact that there's a syntax here, right? Visibility, which can either be private, public, private, protected, default, right? Default is also called package, as they taught us there. The variable name, right? And obviously, I mean, you want to be very particular about things like the convention that is used insofar as the programming language you're using is concerned, right? Can't quite remember the convention used for Java variables, right? I don't know if I don't know if it's sentence casing or something with the initial letter lowercase, I don't know. And then full colon, the data type, or just the valid data type with the casing is important as well. And the casing is important because you want to automatically generate this code, right? Followed by the equal sign if you have a default value, and then the value itself, right? So all the same things that we have here. So if we had another variable, let's say it's maybe default or something, or like protected, not default. Default is that, right? Tilde. Let's say it was public, right? And example attribute, and the data type was double, right? I don't know if double in Java is lowercase or uppercase. It mixes things around here. It's double, 2.5, right? This is what you would do. Right? And I've mentioned this in the past that for certain tools like Lucidchart, you cannot, there's no easy way of doing this. You have to type, you have to know what these different notations imply and type them out accordingly. But if you're using tools like Visio and Dia, for instance, what you will notice is the moment you start writing class diagram, the moment you start creating class diagrams, right? If I put class here and this digital object, class name digital object, it's just point and click here, right? I just double click into it. I start specifying attributes, right? So observe, oh, this is the thing. This is where we do the test, guys. Let's say it's an app. Is there a part where I say abstract? There's no provision for interface, right? There we go. Abstract is italic. I'll change it. It's not an abstract class. Apply, normal font, right? But what I was trying to say here is that if I have attributes and I want to create an attribute, say identifier, all I have to do is I say identifier. The type is string, right? The visibility, it's private. It's point and click. Scope is class, which is like it's going to be static, right? And I see it's not, is it scope? Maybe it's different here. I thought maybe scope means something else. But so this is the thing here, right? This is the thing here where you specify these things. Default value here, maybe it's going to be, I don't know, 1, 2, 3, 4, 5 V's or something, right? So this is what I'm trying to say is depending on the case tool that you're using, like in this case, Dia would be perfect, or too similar to Dia would be perfect because you are not forced to start remembering, although it's not that hard to remember. Say, what does private mean? All you do is use this pop-up, right, to help you, to help guide you, right? You just go to the appropriate thing. I'm wondering why this thing doesn't have, wow, it doesn't have provision for an interface, right? Wow. We must Google up interfaces in Dia, right? I don't know. Is this making sense though? So the things that you need to have, right? When you're specifying attributes, is the visibility, which can either be private, public, private, protected, default, or default, right? The variable name, the data type associated with the variable, and the default value. That's all. And then you're done. You just follow through with this syntax here. Now, the visibility are these things here, right? The upper head in slide number 70 here, right? Get the static part here, but just concentrate on these things here. You signal. Do you remember what Mr. Mbewe taught us about what it means when a class is public? What does that entail?
So,
yes.
Yeah, just a quick one. So, like the visibility is just the same as the modifiers, because I think that's the term we used, just for clarity's sake.
Yeah, I mean it's one of yes, the modifiers. Okay, what do the modifiers do?
All right.
What do they do? What's the difference between public?
The same thing as what you're talking about.
What is the difference between public and private?
That's my question, or everyone's question.
Sorry?
Oh no, I thought that.
No, it's a question for everyone, right?
I thought that was my question. It's okay.
No, it's your question then. What's the difference between public and private? What does it mean when we say we have a private attribute? If this was private, what does that mean?
Can I take this one? It means that the method cannot be invoked outside the class. It cannot be used in the same class.
Right. So method or attributes can only be used in the class, right? Yeah. So if this was private, if the identifier was private, which it should be, right? They tell you, I don't know if you discuss this idea of information hiding, right? Very important. Yeah, I'm sure you discussed this. There's a reason why by convention your attributes must be private. The only way you access them is through the getter and the setter methods, right? But anyway, that's neither here nor there. But the thing is that you have public, you have private. Public means can be accessed from anywhere. Private means just from within this class. Protected means only subclasses can access that thing. It's protected, right? So if you're not a child class, you will not access something that's protected. Default means it's going to be accessible in the package, right? Remember packages when you're creating these things. You must remember these things. These are important things, right? But anyway, so that's fine. We're not discussing that here. We're discussing something else. You discussed this with Mr. Mbewe, I guess. Right. So this is it here, and so I was going to talk about operations, but maybe we'll continue the operations on Thursday or something. I'm looking at the time, and then we'll probably wrap up with the different relationships that exist, and then maybe we can then start. We can tie different pieces together, and then start our discussion of sequence diagrams, and then we'll be done with lecture series number 9 or something. And the idea is once we are done with this, we want you to churn out the second version of the SRS document that will be complete. Unless if there are questions, guys, I guess I'll just say that we can call it a night, and then I'll see you, I believe it's day after, it's Thursday or something, I don't know. Are there any questions? If there are no questions, I would like to insist that please go and revisit the parts that you discussed with Mr. Mbewe to do with object-oriented programming, especially, just so that you remind yourselves of these things, because it turns out that once you start looking at sequence diagrams, we're actually implicitly talking about the interaction of the different objects, right? Instances of the classes, and so it would be a good idea, I guess, if you know what we're talking about here, right? If you've forgotten, you want to remind yourself of what was discussed here. Okay, it doesn't look like people have questions, so goodbye. Have you started using Lucid Chart for drawing your ER diagrams in 3010 for the assignments? Okay.
No, we haven't. No, we haven't.
Well, maybe you should start now, right? Now that you know that Lucid Chart, Lucid Charts can be used to do that. Very powerful tool. So just use the chart. Most of these tools, diagramming tools like Dia, Draw.io, Visio. Visio used to be a very popular tool, right? Back in the day, because these cloud-based solutions were not there. So this is what I'm talking about. So if Mr. Wally has given you an assignment, or you're trying to work on a project that you're working towards, you can just create a new shape. I don't know if I mentioned this already. And then you select the appropriate diagram here, entity relationship diagram. You say use this diagram, and then you start creating your relationship and your entities. If you want, you can create it from the template as well. This is a very thing, right? A very powerful tool, by the way. I don't know if people realize the real power of this, but probably not. Anyway, probably not. You never appreciate this. If you want, you can also look at the templates, and boom, you even have the cardinalities, right? That the things that have been introduced to you as cardinalities. Incidentally, the funny thing is that the syntax kind of changes, and this ties on. It's tied to what someone was asking. Is it the last time we had class where I was saying, but what's the difference between an entity and an actor, right? And I was telling him it's contextual. Same goes for like in your diagrams. I think you call these things cardinalities, right? So many to one, right? But when you're looking at class diagrams, class diagrams, you notice that the phrasing changes, and I'll start making reference to things like, oh, multiplicities or something. All right, if I were you, I'd do this, right? Play around with these things a lot more so that you learn a thing or two. Thank you, and see you when you see me. Bye-bye.
All right, bye.